If Los Angeles lost its water supply, it wouldn't collapse overnight. It would just slowly empty out. Because one of the largest cities in the world, home to 13 million people, exists in a place that was never meant to support it. No major river, almost no rain. No natural water system that explains a city of this size. So, where does the water actually come from? Somewhere else. And that somewhere else is starting to run out. Look at a rainfall map of Southern California and the problem becomes obvious. Los Angeles gets about 15 inches of rain a year. London gets twice that. Houston gets at least 3 times as much. There's no massive river running through the city, no natural source that could support millions of people. And yet, here it is, a global city built on water that had to be engineered, diverted, and taken from somewhere else. This isn't a future problem. It's already happening, and to understand why, you have to go back to when Los Angeles decided it didn't want to stay small. In the early 1900s, Los Angeles was already running out of water, so the city went looking for it. About 230 miles northeast, in the Owens Valley, a river fed by Sierra Nevada snowmelt supported a thriving agricultural region. Los Angeles quietly bought up the water rights, and in 1913 completed the Los Angeles Aqueduct. From that point on, the water didn't stay in Owens Valley. It flowed south. The farms collapsed. Owens Lake dried up, turning into one of the largest sources of dust pollution in the United States. And Los Angeles used that water not just to survive, but to grow. The aqueduct didn't just supply the city, it built it. And once that system worked, it changed how the city thought about growth. If you like videos that break down how geography shapes cities like this, consider subscribing. I post new videos every week. Water wasn't a limit anymore. It was something you could go out and get. As long as there was another river, another valley, another system somewhere farther away, Los Angeles could keep expanding. The question wasn't whether the city had enough water, it was how far it was willing to go to find more. And eventually, it needed to go farther. The next source was the Colorado River, a massive system draining about 246,000 square miles across 7 US states and Mexico. For most of history, it flowed all the way to the Gulf of California. Today, in most years, it doesn't. The river runs dry before it reaches the sea, because nearly every drop has already been used up or diverted. In 1922, the states along the river signed the Colorado River Compact, dividing up the water. But there was a problem. They based the agreement on measurements taken during an unusually wet period. The river was never going to reliably deliver what the compact promised. At the time, it didn't seem like a problem. The river looked massive. The basin looked empty. Demand was relatively low. But over the next century, that assumption broke. Cities grew. Agriculture expanded, and every state built systems to claim as much water as possible. By the time the limits became clear, the system was already locked in. Everyone was depending on water that didn't actually exist. California secured the largest share. And in the 1930s, Southern California built the Colorado River Aqueduct, another massive system carrying water over mountains and across deserts to feed Los Angeles. That system worked for a while, but it was built on an assumption that wasn't true. Today, the Colorado River is under extreme pressure. Lake Mead, its largest reservoir, has dropped to historic lows, at times below 30% capacity. Climate models suggest the river's flow could decline by another 20 to 30% by mid-century. And the system that divides it promised more water than it actually has. So Los Angeles needed a third source. That source came from Northern California. The State Water Project, one of the largest networks of canals and pipelines ever built. Water is captured in the Sacramento-San Joaquin Delta, then pumped hundreds of miles south. To make that work, it has to cross the Tehachapi Mountains, and that means lifting water more than 2,000 feet uphill, the largest single water lift in the world. This is one of the most energy-intensive water systems ever built. Moving water over that distance requires enormous amounts of electricity. In effect, California is constantly burning energy just to move water to where people live. It works, but only as long as both the water and the energy are available at scale. And the water isn't always there. In major drought years, deliveries drop dramatically. In 2021, some regions received just 5% of the water they were supposed to get. 5%! The system was designed for a California that no longer reliably exists. The snowpack that feeds it is shrinking. And when that snow melts too quickly, the water runs off before it can be captured. The system still works, but the supply behind it doesn't. And this is where the pattern becomes clear. From a distance, it looks like three separate solutions: Owens Valley, the Colorado River, Northern California. But it's really one system, repeating itself at a larger scale each time. Local water runs out, so the city reaches farther. That new supply enables more growth, and that growth creates the need to reach even farther again. Each step works, and each step makes the system more dependent on something it doesn't control. Los Angeles didn't grow despite its lack of water. It grew by solving that problem, over and over again, and each solution made the next problem bigger. Now, all of those systems are under pressure at the same time. The Colorado River is shrinking, the snowpack is declining, environmental restrictions are tightening. And other regions that depend on the same water are pushing back, because Los Angeles isn't just competing with nature, it's competing with other people who rely on the same system. Cities in Arizona, farmers in the Central Valley, entire regions whose economies depend on access to the same shrinking supply. Every reduction has to come from somewhere, and increasingly, those trade-offs are no longer theoretical. So what does that mean in practice? It means growth is getting harder. Regions around Los Angeles that were built on the assumption of continued water expansion are starting to face limits. It means agriculture is already being forced to scale back. Farmers are leaving fields empty. Wells are running dry. Entire areas are sinking as groundwater is overused. And for Los Angeles itself, it means trying to replace what used to come from somewhere else. Recycling water, capturing stormwater, rebuilding local supply. Those efforts are real and they matter, but they don't fully replace what's being lost. Because for more than a century, Los Angeles has depended on water it doesn't control, and that system is starting to break down. So here's where we land, and it's not a comfortable place. Los Angeles isn't going to disappear. A city of this size doesn't just shut down. The infrastructure will hold, the water will keep flowing, for now. But the system that built it is running out of room. For more than a century, the solution was always the same. Go farther, build bigger, bring in more. Now, for the first time, that strategy has nowhere left to go. There are no more valleys to drain. The Colorado River is already overdrawn. The snowpack is already shrinking. Los Angeles grew by using other people's water. Now those places are starting to need it back. And for the first time, the city can't just go farther to solve the problem. And it's not entirely clear what happens next. If you want more videos like this, explaining how geography shapes the world, you can subscribe here.